Hi, this is Rajnikant Mishra. Welcome you all to my YouTube channel. My topic of today's lecture is how to find a day from the date. It means how can you find a day when date is given. Before starting this chapter, let's take a view of previous question. If n is divided by 3, 4, 5 and 6 successively, it leaves remainder 2, 1, 1 and 4 respectively. How many such 4-digit numbers are possible? This is a question of LCM and SCF chapter. Let a number n. First divide this number by 3. Here is the quotient, here is the remainder, which is 2. Then divide this x by 4. Here is the quotient, the remainder is 1. Again divide this quotient by 5. Here is the quotient, which is z, and the new remainder is 1. Then again divide this z by 6. The remainder will be 4. Now find out how many such 4-digit n are possible. If you want the solution of this question, then check the concept video link given in the description box. Now we are going to learn some basic concepts of calendar which we are using today. The calendar which we are using today is known as Gregorian calendar. It is globally accepted civil calendar, which is also known as the Western calendar or Christian calendar. It follows a 7-day week schedule. It means after each 7-day cycle, the fixed sequence of days repeats. According to this calendar system, the first day of 1 AD was Monday. It means the starting day of the calendar system is Monday. Here, we will give some numerical value to each day for the purpose of calculation. These values are, here Monday is equal to 1, Sunday is equal to 0, and others are as follows. In calendar system, there are two types of years, a leap year and a non-leap year. The question is, how can we find a year is leap or not, and what are the properties of leap and non-leap year? For example, let's take a year 1998. And we have to find this year is leap or not. In this case, there are two possibilities. Either this year is not divisible by 100 or it is divisible by 100. In case the year is not divisible by 100, then we will check. Either this year is divisible by 4 or not divisible by 4. In case this year is not divisible by 4, then this year is a non-leap year. If this number is divisible by 4, this year is a leap year. In non-leap year, February has 28 days. And in case of leap year, the February has 29 days. Now question is, how to find a number is divisible by 4 or not? Just take last 2 digits of this year and divide it by 4. Here, this 98 is not divisible by 4. So, it's not a leap year. Means in 1998, the February has only 28 days. Now, in case, if the year is divisible by 100, for example, 1900, then there are two possibilities. Either this number is not divisible by 400 or this number is divisible by 400. In case this number is not divisible by 400, then the year is non-leap. And if this number is divisible by 400, then year is leap. In this case, 1900 is not divisible by 400. So, 1900 is non-leap year. According to this definition, 100, 200, 300, 1800 and 1900 are non-leap years. And 400, 800, 1200, 1600 and 2000 are leap years. In non-leap years or normal years, there are 365 days. And in leap years, there are 366 days because of 29th of February. The concept of odd days. As we know, the Gregorian calendar follows a 7-day week schedule. Means after each 7 day, a fixed sequence of days repeats. Assume today is Sunday and you have to find 23rd day after it. Here, each 7th day is Sunday, So remove all 7-day cycles and find out the remaining days. 23 mod 7 is equal to 2. 7 3s are 21 and the remainder is 2. Here, this 2 is known as odd days. Here is the formula of odd days. N mod 7. Here n is the number of days. Mod is modulo operator which is used to find the remainder. Number of odd days in leap years. As we know, in leap years there are 366 days. 366 mod 7 is equal to 2. It means in leap year there are 2 odd days. In non-leap year there is 1 odd day because the number of days are 365. Here is the odd days in different months. As we know, January has 31 days. 31 mod 7 is equal to 3. In case of non-leap year, February has 28 days. 28 mod 7 is equal to 0. In case of leap year, odd days equal to 1. Similarly, in case of March, the odd days equal to 3 and so on. Here, this February is a special case. And most of the months have 31 days. And there are only 4 months which have 30 days, that are April, June, September and November. June, November, April, September. Keep this rhyme in your mind. These 4 months have only 30 days. February is exceptional and rest all months have 31 days. Now, we are going to calculate the number of odd days in a century. From 1 AD to 100 AD means in first century, there are 100 years in this period. In normal cases, each 4th year is a leap year. So, this 100 by 4 is equal to 25. Means there should be 25 leap years in this period. But as we know, 100 is not a leap year. So, 25 minus 1 is equal to 24 leap years are present in this first century. 100 minus 24 is equal to 76 non-leap years are present. Now, each leap year has 2 odd days and each non-leap year has 1 odd day. Means total number of odd days are 24 into 2 plus 76 into 7 divided by 7. 24 by 7, the remainder is 3. 76 by 7, the remainder is 6. 3 into 2 is equal to 6 plus 6 into 1 is equal to 6 by 7. 12 by 7, the remainder is 5. This theorem is known as remainder theorem. Means in the first century, the number of odd days equal to 5. Similarly, in the second century, from 101 AD to 200 AD, the number of odd days is equal to 5. Because 200 is not a leap year. In third century, the number of odd days is equal to 5. But in fourth century, here, this 400 is a leap year. So we have to add one more odd day in 5. The total number of odd days is equal to 6. Total number of odd day in these 400 years, 5 plus 5 plus 5 plus 6 is equal to 21. 21 mod 7 is equal to 0. It means in 400 years, the total number of odd days is equal to 0. Or we can say the calendar repeats itself every 400 years. Question number 1. Find the day on 14th September 1967. Step 1. First we have to calculate the total number of odd days from 1 AD to 1600 AD. Here there are 4 cycles of 400 years. and each 400 year, the number of odd days is equal to 0, means 0 into 4 is equal to 0. From 1 AD to 1600 AD, the total number of odd days is equal to 0. Now in step number 2, calculate number of odd days in 17th, 18th and 19th century. It means from 1601 AD to 1900 AD. As we know, in each century, the number of odd days is equal to 5. So the total number of odd days is equal to 15 mod 7 is equal to 1. In next 3 centuries, the number of odd days is equal to 1. Step number 3. Now we have to calculate the number of odd days from 1901 AD to 1966. Here, total number of years is equal to 66. Number of leap years is equal to 16. Non-leap years are 66 minus 16 is equal to 50. 16 leap years, 2 odd days in each leap year, 50 non-leap year, 1 odd day in each non-leap year by 7. 16 by 7, remainder is 2. 50 by 7, remainder is 1. 2 into 2, 4. 4 plus 1 is equal to 5. Means total number of odd days from 1901 to 1966 is equal to 5. We have to calculate the number of odd days from January 1967 to August 1967. 1967 is a non-leap year. So the February has only 28 days and the number of odd days in February is equal to 0. Now we have to calculate the number of odd days from January to August. Now 3 plus 0 plus 3 is equal to 6. 6 plus 2 is equal to 8. 8 minus 7 is equal to 1. Means 1 odd day. 1 plus 3 is equal to 4. 4 plus 2, 6. 6 plus 3 is equal to 9. 9 minus 7 is equal to 2. Now this 2 plus 3 is equal to 5. It means number of odd days from January to August is equal to 5. Step number 5. Now we have to calculate the number of odd days in rest 14 days of the September. 14 mod 7 is equal to 0. Total number of odd days 5 plus 5, 10, 10 plus 1 is equal to 11. 11 mod 7 is equal to 4. Here 4 represents Thursday. It means on 14 September 1967, there was Thursday. Question number 2. Find the day on 25th of April 1868. Step number 1. First we have to calculate the number of odd days from 1 AD to 1600 AD, which is equal to 0, like in previous case. Step number 2. We have to calculate the number of odd days in 17th and 18th century. It means from 1601 AD to 1800 AD. In each century, number of odd days is equal to 5. 5 plus 5 is equal to 10. 10 mod 7 is equal to 3. Means in these 2 centuries, total number of odd days is equal to 3. Now step number 3. Here we have to calculate the number of odd days from 1801 AD to 1867 AD. There are total 67 years, out of which 16 are leap years and rest 51 are non-leap years. 16 into 2 odd day per leap year, 51 into 1 odd day per non-leap year by 7. 16 by 7, remainder is 2. 51 by 7, remainder is 2. 2 into 2, 4. 4 plus 2 is equal to 6. 6 by 7, remainder is 6. Step number 4. Here we have to calculate the number of odd days in January, February and March of 1868. 1868 is a leap year because 68 is divisible by 4. So February has 1 odd day, March has 3 odd day, January has 3 odd day. 3 plus 1 plus 3 is equal to 7. 7 mod 7 is equal to 0. Means in these 3 months total number of odd days is equal to 0. Step number 5. Here we have to calculate the number of odd days in rest 25 days. 25 by 7, remainder is equal to 4. So the number of odd days in rest 25 days is equal to 4. Now total number of odd days is equal to 0 plus 3 plus 6 plus 0 plus 4 is equal to 13. 13 mod 7 is equal to 6. Here 6 represents Saturday. It means on 25th of April 1868 there was Saturday. Here is your homework. The day on 18th of September 1977 was Sunday. A couple was married on this date. How many marriage anniversaries would fall on Sunday in the next 15 years? Second question. The calendar of 1898 will repeat in which year? Question number 3. If the Republic Day of India was celebrated on Friday in 1996, then on which day will it be celebrated in 2036? Republic Day of India is celebrated on 26th of January each year. The solution of these questions will be given in the next video. If you like this video, hit the like button, share it with your friends, and never forget to subscribe and hit the bell icon so that you will never miss any important update.